Hi class, let's take a look at problem M. It looks a little bit messy, but it's not that bad. What I'm going to do is I'm going to separate each of the terms and then put them together. So technically what I'm going to do here is simply put 4 over 6 and then we'll cancel this one times a to the 10 minus 3 times b to the 5th minus 2. And then at this point, well, 4, 6, this is 2 times 2, and 2 times 3 times a to the 7th and b to the 3rd. And then we can cancel the common factors of the 2's. So our final answer for this one, it's going to be 2/3, a to the 7, b to the 3rd. You could also express it as a fraction. If you go that route, then, as a fraction with the a and the b on the top, this will be 2 a to the 7, b to the 3 over the values of 3. And let me fix that 3. Okay, that's it for this one. Let's move on to the next problem. And good news on the next problem, this one will take one step. So this one, as you exponentiate, meaning as you raise to the second both of these, technically you will have the 5 to the second over the 7 to the second. And this could be considered a final answer since all your values are prime, or they may want you to expand. So in this case, you would have 25 over the values of 49. That's it for problem N. Let's take a look at the next problem. And remember that the exponent gets applied to each one of these. And let me just rewrite this step. So you're going to end up with x to the 5 times 4 over y to the 3 times 4. And this is x to the 20th over y to the 12th. This is a perfectly fine answer. I'm just going to do one more step because some of the problems may ask you to put disclaimers on variables that could make the expression undefined. So in this case, x to the 20th over y to the 12th, as long as y is not equal to 0. Now, I'm just rewriting this extra step because technically, remember that in expressions, you can evaluate terms. So you can plug in x's, you can plug in y's, you can plug in any values except your denominator being 0. So that would only cause a problem at the bottom. That's it for this one. Let's move on to the next problem. And we do have to be careful on the next problem. The 2 is going to be applied to each one of the exponents. So let me rewrite it as -1 squared times technically 4 to the second times t to the 10 times 2 over u to the 6 times 2. And then the -1 to the second simplifies to simple 1. So this will be 4 squared times t to the 20th over u to the 12th, or if they want it in prime factor form, I'm just going to rewrite the 4 as a 2 to the second squared or 2 to the 4th. So in this case, you could express it as 2 to the 4th times t to the 20th over u to the 12th, being one possible answer. Another way to express this one would be with a disclaimer. This will be the 2 to the 4th, t to the 20th, and then u to the 12th, as long as u is not equal to 0. And then you could actually go one extra step and then evaluate the 4 to the second or the 2 to the 4th, which is simply 16 t to the 20th over u to the 12th. So any of these answers are perfectly fine. I am putting the disclaimer on at least one of them, so in case it shows up on the homework assignments. That's it for this problem. Let's move on to the next one, and let me just double check again all the values, and we're good. Okay, so on problem Q, we are getting a similar problem like the one above. We're going to distribute the 3 to all exponents, and here I'm just going to rewrite it as -1 to the third times 4 to the third power t to the 10 times 3 over u to the 6 times 3 and w to the 3 times 3. Now, as you exponentiate the -1 to the third, that's going to be -1. So this will be -4 to the third, t to the 30th, whoops, that's 36, 30th, u to the 18th, and w to the 9th. And let me do the same step that I did with the actual 2 from the previous problem. So you have a 4 to the third. This is equal to 2 to the second to the third power, or 2 to the 6th. So you could express this one as -2 to the 6 t to the 30th over u to the 18th, w to the 9th as one possible answer. Let me exponentiate the 4 to the third or 2 to the 6th, which is simply going to be the values of 64. So you're going to get -64 t to the 30th over u to the 18th, w to the 9th. That's another answer. And then to this last answer, I'm just going to put the disclaimer on the side, which technically means that u and w cannot equal to 0. And let me just rewrite that fraction in a different form. So I'm currently putting the negative on the top. You may see it on some problems with the negative on the side. So 64 t to the 30th over a u to the 18th and a w to the 9th, with the disclaimer that u times w cannot equal to 0. Putting u and w cannot equal to 0, it's sufficient, because if the first power of these two are not equal to 0, raising it to the 18th or to the 9th are not going to make them 0 either. Let me take another look, but that's it for this one. And it was a little bit messy. Also, keep in mind that there's multiple ways of expressing the answer. If they mention prime factor form, then that would be the one with the 2's, where they want all bases to be in prime form. Let's move on to R. And good news on this one, it will take a simple step. So this is automatically 1. And let me explain. The formula that we were talking about above, in this case, let me point out to the formula. Oh, I skipped it. Here. So this is the formula that I'm referring. A can be any base. So the way that the problem is being expressed, the base happens to be multiple terms. In this case, well, we technically have, I think, all the terms from the previous one, or very similar to the previous one, except that your exponent is 0. So the formula that I'm using is that a to the 0 is equal to 1. And in this case, the base represents a fraction with variables. As long as this is some sort of a base raised to the 0, automatically 1. So that one didn't take much to do. And I think we reached the end of these set of problems. So once again, for problem R, because you have a base raised to the 0 power, automatically 1. And this is the formula that we're using.